Hello everyone, welcome back. In this video, we are going to continue to talk about dividing polynomial. In previous video, we talked about how to divide a monomial. We just need to follow some basic principle here. And in this video, we are going to deal with a little bit more complicated situation. As you can see here, we are going to divide binomials. So in general, when we divide a polynomial, we have two ways. One is called long division. And the other one is going to be the one we are going to introduce in this video. It's called a synthetic division. So if you're interested in long division, you can do more research on that. So let's see how do we set up the synthetic division and how do we perform this method. So the first thing in synthetic division, we need to set up the big L here. And then we are going to focus on the coefficient for the top part, which is, as you can see, invisible 1, then -2, then -4, then 1. So this line is coming from the coefficient of the top part. So next, I'm going to answer this question. What is x plus 1 equal to 0? Then x is -1. So I'm going to use this number -1 outside the L here. So it's like a zero product property. That's how we're going to use this one to help us to perform synthetic division. Next, I'm going to repeat this process. First, I'm going to copy down this number 1 here. Then I'm going to use a number on the bottom to multiply -1. So -1 times 1 is -1. Then the inside number I'm going to add. So -2 plus -1 is -3. I continue this process. -1 times -3 is 3. And then I add this two number is -1. Lastly, -1 times -1 is 1. Next, I'm going to add this two is this. When I finish this, I'm going to write down the final answer. This is the coefficient I'm going to use. So how do I write down the answer? Since the highest degree here is x to the third, when you divide by x, the degree is going to reduce by 1. So the highest term here is going to be x squared. Since the coefficient is 1, so I keep this invisible as 1 here, then I use descending order for the exponent, 3x minus 1. Lastly, what's this? It's actually our remainder. So I'm going to write this way as plus 2 over x plus 1, because the original question we divided by x1, so this is our final answer. Okay, again, I think you might get confused about this one, or you are not so familiar with this process yet. So we are going to continue another example to use a similar way to deal with this. But again, you can definitely pause the video or just rewatch this part to be familiar with this case. Okay? So next example, we are going to deal with similar situation, but there is something is missing, so we need to pay special attention here. So we are still going to use synthetic division to deal with this one. And this time, check, what do I have on the top part? We have x to the third, 4x squared, then minus 11. So if you pay special attention here, it seems that we do not have the x terms here, right? So in order to use synthetic division, this time we are going to have a little bit different situation to set up. So first, we're still going to set up the L part. And then I'm going to write down the coefficient. X to the third coefficient is 1. And then continue is 4. Since I do not have any terms regarding the variable x, so the coefficient for the x term is going to be 0. Then continue, the constant term is -11. So that's only difference here. 1, 4, 0, then -11. So next, I know x equal 1 to make it 0. So the 1 is like a reverse number I put outside. So I'm going to continue the process here. I copy down 1. Then 1 times 1, 1. I plus this 5. And then 1 times 5 is 5. I add them, is 5. Continue, 1 times 5 is 5. Then add them again, so it's -6. So as you can see here, it's the remainder -6. How do I write down the final answer? Since the highest degree is third power, divided by x here, so the degree reduced by 1 is x squared, because the invisible 1 as coefficient. We use descending order to write the exponents here, so 5x plus 5. Finally, -6 over x minus 1. Okay, so that's our final answer. Again, the last one is stay as remainder. So again, I just used two examples to demonstrate what is a synthetic division to deal with this situation. again, the process is not complicated. The only part you need to pay special attention is how the process goes. When do we add? When do we multiply? And if we miss any terms here, you need to be careful to put a coefficient as 0 to demonstrate this part. Thank you so much for watching and studying this, practice with me. I hope this video is helpful. See you soon, everyone.